and edit. Go up and clear your list. We're going to type in the new X's and Y's. We are doing the one that says NASA. It's student practice. It doesn't have a number. As you guys are working, like, if you're getting error messages, I can't see your little screens, so I can't stop doing what I'm doing to help you if you don't speak up. So if you get, some sort of error or something's going on and you don't know what's going on, like, just give me a stop for a minute. Say my name. So you have to have the same amount. So when you miss something, 10, 15, 20, 25, 30, 35, 40, 35. All right, do you guys have them typed in? Yeah? Nay? Nah? You not clear your list at first? Or?
Yeah, I typed in the first one.
Gotcha. I don't even know why we started with this one. That's not where I'm supposed to start today. So he's catching up anyway. Oh, we didn't even do the first page yet. We'll come back to that. Just put it off to the side. All right. So today we are writing equations to model data, and the equations that we're writing are linear or quadratic. We've already learned how to do linear, so now what they're doing is they're combining linear and quadratic together. So the first thing that I want you to learn about is these are called finite differences. These are called finite differences. Finite being not infinite. Finite being there's an end to what we're doing. And in this paragraph where it talks about finite differences, it says that, first of all, data has to have equally spaced inputs, which is the x values. So the first thing I do is I look at my x's, and they are all evenly spaced. So I can continue to do what I'm about to do. But that's first thing is if the x's are not evenly spaced, you can't do what we're about to do. And then we're going to analyze the y values. We're going to look at the output. And what we're going to do is it's called differences. If the equation is linear, then we will have constant first differences. If the equation is quadratic, then we'll have constant second differences. What does that mean? That means look at 9 to 4 and say, how do I get from 9 to 4? Add or subtract? Subtract 5. How do I get from 4 to 1? Subtract 3. From 1 to 0, subtract 1. From 0 to 1, add 1. From 1 to 4, add 3. From 4 to 9, add 5. Those are differences. Now, these are not constant. They're not the same number every single time. So this is the first differences, but they are not constant. So I know this is not linear. So then what we do is we take these differences and we do it a second time. So from -5 to -3, add 2. And then add 2, add 2, add 2, 2. So these are constant second differences. And because it took us 2 rows before we had the constant ones, that tells us that when we have our equation, it's going to be some sort of x squared in the equation. It's going to be quadratic. So my final answer here is quadratic. But everything else is me just giving you notes. If we do 2 lines and in my second line they're constant, then I know my equation is going to be x squared, which is called quadratic. Okay? The shortest way for me to find these differences, especially when we get to bigger numbers, the shortest way, I am going to use my calculator on some of these, but the shortest way is to take the second number minus the first number. We take the second number minus the first number, that's going to tell you the difference. So if I were looking at 9 to 4, I would do 4 minus 9, which is -5. That's how I got that first number there. So if you can't figure that out in your head, you can use your calculator as well. So what I want you to do is I want you to try finding the differences for these 3 examples down here. And if they are not constant the first time, then do a second one. And if they're not constant the second time, then do a third one. Let's see how you do. Take a couple moments, and I want you to find these differences. We do it to the y value. Start with -5 minus -8. Subtract -5. Subtract -8. -8. There you go. So that should be 0. Now do -2 subtract -5. You're going to take the second number, 94, subtract 135 to find the difference. So the answer itself, like for this one, it was quadratic. Oh. So what would the answer be? Yeah. You guys are trying all 3 of them. If you're just sitting there, you've done 1 and you're just waiting. Actually, we're doing all 3. So if I do 1 minus 3, does that give me 4? Right, that I need to know 1 add and subtract what number is equal. Like, you were going this way. Okay, well, this should be sufficient. Maybe so if you're going to use this, you have to use the second number. I didn't write it down. Second number minus first number. I didn't fit it all in one line. You only wrote the second part. Second number minus first number. Make that look a little bit better. Oh, now you have to do it again. You go up here. Do negative 33 minus, I don't know what that is. 41. Like, what you start on this. You didn't actually do the second one. Yeah, so go back and do like negative 33, take away negative 41, find those numbers as well. When you look at these numbers, like negative 9, negative 1. Second, smaller, bigger. Right, so it shouldn't be happening. That is true, you know what that's called. We'll go over it. See, I covered it up. All right, so I have the first two up on the board, and I've been walking around, so most of you were there anyway. The first one was linear, because we had the first constant difference, and they were all the same number. So that would be linear. The second one, we did the first difference, and they were not constant, so we did a second difference, and they were all plus 8. So that was quadratic. So linear is f of x is x to the first. Quadratic ends up being x squared. What happens when you do 3 differences before they're constant? What do you think that's called? Or what do you think x to the what? It is x to the third. Does everybody know what x to the third is called? It has something to do with cubes. Anybody know what it's called? Everybody's afraid to say something wrong. It's called cubic. But that's not what we're studying today, but I thought I'd throw it in there because there's many different ways, many different equations that you can find using this way. Now, is when you do data in like real life, is it always like perfectly spaced data? No. So that's why we use the regression feature when it is not perfectly spaced data. So that's where we started the notes today. Let's pick back up there. We were at example 2, or it's not 2, the one over NASA. And this says that it tells you in the question that that NASA can create a weightless environment by playing a plane in a parabolic path. That says that this is going to be quadratic. It's going to be parabola. And this shows the height in feet of the plane t seconds after starting the path. So t is time, height is how far up the plane is. We have to find the function to approximate the height at which 20.8 seconds is when they begin to experience weightless environment. We have to find the height for that. Okay, so we type in our numbers, and then what we're going to do is find the regression. So we go to what? Stat. And then from stat, we've already typed in our numbers, so now we're going to calculate. So go over to calculate, stat, calc, and then what? 5. We're going to choose quadratic regression, number 5. And then you enter until you have an answer. And I have an exact answer. Y equals negative 11x squared plus 700x plus 21,000. So we have our equation. Now what we're going to do is we're going to graph it, and then we're going to find the value when x is 20.8. So to graph it, we go to y equals, and if there's anything in there, you got to clear it out. Also at the top, see how mine says plot 1 and it's darkened? Yours should look like that too. It should be darkened in because we're telling the calculator we're about to do statistics, data. So now I'm going to copy the equation. To copy it, we do vars, and then number 5, statistics, over to EQ, and enter. And it copies it there for you. Do you have to copy it? It's easier, yeah. Especially, I mean, not so much right, like this one's not that hard, but when they have those long decimals, it's definitely easy just to copy it. Okay, and then before you graph it, you have to check your window, because your window has to match this data. Right now, my window, if I'm looking at my y values, definitely is not in the thousands. So I'm looking at my x's, and guys, always make your window bigger than you need it. Always make it bigger than you need it. 0 to 50, and I'll count by 5s. And then the height, I'm going to make it 0 to and maybe 35,000, and I'll count by 5,000. Sure. The counting by part's not really that important. But just make your window bigger than you need it. When I do go to find this value, just heads up, when I do go to find this value over here, this 20.8, if my x values are not big enough, 50 is big enough. But if for some reason my x values were not big enough, your calculator will give you an error when you go to try to find it. So it's better to just like make it bigger than you need anyway. So once we have our window set up, hit graph, and you'll have your equation, and you'll have your graph going through it, your line of best fit going through it. And we have to figure out what height is after 20.8 seconds. So how do I find the value? Where do I go on my calculator to find value? Remember? Second trace. That second trace button has a lot of good things underneath it. But number 1 is value. And we will type in 20.8, and it immediately tells you the answer. At 30,801 feet, approximately. Okay. Let's try another one. Please, stop me, ask me a question if you're having errors on your calculator, especially if people next to you are like, I don't know what's wrong here. Stop me if you need help. All right, this one says the table shows the estimated profits in dollars for a concert when the charge is X dollars per ticket. Write and evaluate a function to determine the charge per ticket. What charge per ticket should be the maximum profit to maximize profit? I don't know why I can't read today. Stat, edit, clear the stuff from before. Once you've typed it in, go find the equation. I'll catch up to you. Once you've typed it in, go find the equation. Well, you were supposed to go up and clear before you started. Delete might work. Hit delete. Okay. But if you go up and clear, you won't have to worry about that. So for finding the equation, we go under Stat, Calculate, and then Quadratic Regression, and we get an equation. Before I even graph this equation, my A value is negative 100. What does that tell me about the parabola? If it's a negative number, it's going to be reflecting. So I know that this graph is going to somewhat look like, that-ish. And the reason why I'm asking is because this says, right, an evaluated function to determine what charge per ticket should maximize the profit. So we're trying to find how much to charge per ticket, like what the X is, so that we can have the highest profit. Does that sound like something maybe you might want to do if you own a business someday? Get the highest profit possible? So we need to figure out what ticket charge maximizes this. So if I'm talking about the max Y value, what part of the graph am I talking about? The vertex. So we're going to get this graphed, and I'm going to re-go over, because I did this on Friday. I'm going to re-go over how to find the vertex. So remember to graph it. You got to copy that equation in, vars, 5, EQ. And then you also have to check your window. So make sure the window fits the data. Looks like 0 to 20 is good. And profit 0 to 10,000. without the line going through it, can you tell it would be a parabola with just the dots? Can you tell it's a parabola? So we need to maximize the profit. We're going to find our vertex. So to find your vertex and a lot of other important things that we do on the graph, it's all under this calc button, which is second trace. So go to second trace, and then when you look at the choices, and you look at what they're asking us to do, what do you think we have to choose? Maximum. Number 4. Number 4. Maximum. And then it will always ask for the left bound, that left boundary. And my x's are going from 0 to 20. It's just asking for a number that is definitely to the left of this vertex, which you don't know what the vertex is. So this is close to it, but like, give me any number that you know for sure by looking at it. It's to the left. 1, 2, yeah, 5, anything like on that side. So all you have to do is type it in, 5. Okay, I have to readjust my light so you can see that line. That didn't help at all. I moved this. Readjust my light again. And it's still not helpful. Even better, right? You guys have a line on yours? Oh, there we go. You see the line? So there's my boundary. Now we need to pick a boundary on the right. So any number that you know for sure is past the middle. I counted from 0 to 20. What's something that's past the middle? 15. You could pick anything that you definitely think is past the middle. And now it's giving you a window and saying somewhere in here that there's a maximum. The calculator's like, don't make me do all the work. At least guess. Guess? Give me an x value that you think. 10? Oh, it is the maximum. We guessed right. It doesn't always happen. So our maximum is 10, 9,000. So what does that mean for this problem? $10. Charge $10. Oh, yeah, why can't you cooperate? Okay, charge $10 per what? Yeah. For a max profit of $9,000. So it's the highest profit you could get. All right, and then we have one more example. And this is, it's supposed to be a student practice, so if you'd like to work ahead of me, that is totally fine. I already have it done, so I can check your answer. But again, we need to find a function that models this data. This data is saying this is how thick ice has to be to support how much weight in tons. That's probably something important, especially if you play hockey. You need to make sure that the ice is thick enough to support the team. So we're going to go to stat. You guys can work ahead. I'm just like talking through it because I'm on the video. Edit. I'm going to go up and clear. And then calculate, this is a quadratic. I think I typed something in wrong. I did this last spell and I'd get a different answer. Yep. So I just rounded the 2 decimals. I got my equation. I'm going to graph it. I'm going to go to y equals. I'm going to clear out what's sitting there, and then I'm going to copy vars, statistics, EQ, regular EQ. Check my window. Maybe 0 to 30. Oops. And 0 to 60. Does that graph look like a parabola? Because you can't see the whole parabola? So this graph is just like part of the parabola. You should imagine, like, my window is only showing part of the data. Your graph could be parabolic, parabola-like. There could be more of it. I just have my window only looking at a piece of it. To me, it looks parabolic, but it does not really look linear. It looks like if I were to connect all these, they wouldn't all connect on a line, but they do connect on this parabola. One of your assignment questions will ask you to do just the scatter plot, like before typing in the equation. It's going to ask you to do just the scatter plot and look at the scatter plot to determine if you think it's a line or if you think it's a parabola. So if your options were line or parabola, you see how it's curving? That's where you're going to want to say parabola. If those are your 2 options, there is one question like that in your homework. And then if it's a parabola, you're going to do quadratic regression. But what if it's not a parabola? What if it's a line? You would do linear regression. We've already covered that. Okay. So this is asking for us to say how much weight can be supported by the ice that is 22 inches thick. So I'm going to go to second trace value, type in 22, and it gives me an answer of 32.36 tons. That's how much can be supported by 22 inches thick ice. There's one more error that people get when they're doing their assignment. And we're going to do it with this one right here. If I wanted to know how much weight was supported instead of 22, let's say if I want to know how much weight is supported by 100 pounds, not 100 pounds, 100 inches. If I want to know how much weight is supported by 100 inches, tell me how you do that with my graph. Tell me what you do. Allie, tell me what you do. So how to get to value? You're right. Perfect. Second trace value. Type in 100. And then, oh, it says error. Nope. Nope. 100 inches. Well, it's not the scale, but it's the window. Yeah. So your window, if your window does not go to x is 100, it won't give you the answer. So all you have to do is say, oh, I want to know for 100. Let me go change my window so my x values now go to 100. Just regraph that. It's okay that it doesn't look as nice anymore. But if your window does not cover what they're asking you to find, then it's going to give you an error. Oops. So now that I've changed my window, it doesn't have that error anymore. So that could be a problem that you encounter. Your assignment is really short. I've already printed it out for you. It's 24, 26, 27, 29 to 32 from the book that I've already printed out. So you can just do it right on here. Okay? Make sure you read the directions. Like I said, like 26A says, determine what type of function you can use. So that's where you're going to do those differences. Before you determine if it's linear or quadratic, you want to do those differences. Okay, you guys have some time to work? You never have that. Ask me questions if you get stuck.